IP. It's a very fast IP address port scanner. It's cross-platform and lightweight. It's old, so it's an aging tool, but you need to know it for the test. It's a very fast IP address port scanner, Angry IP. It's very noisy. It's not very useful in a real penetration test. IKE. IKE stands for, this is a test question, that's why it's in here. I'm kind of interleaving some test questions in here so we don't save them all for the end. So we'll talk about this in a little bit when we get to PKI, public key infrastructure. IKE is the initial key exchange for the public key infrastructure communication protocols. IKE scan is a command line tool that uses the IKE, the initial key exchange protocol, to discover, fingerprint, and test IPsec VPN servers. So it kind of does a little bit of an interrogation on the IPsec VPN servers. Not that useful today. Some people will use it. It's not very widely used today. Another thing is that today you have tools like Kali Linux, which encompass all of these tools. So you'll never really use the individual tool unless you're using it through Kali Linux. Very rarely will you have all these tools in your laptop and fire them off individually. You just download a tool like Kali, and this is kind of built in when you say interrogate a VPN server. It kind of happens automatically under the hood for you. But for the test, you need to know what they are. Another one is ARP scan. ARP scan sends ARP, which is, ARP by the way is Address Resolution Protocol. And so there's DNS, which changes a name to a number. So www.someip.com, somedomain.com gets translated into an IP address, 192.168.1. something. That's a bad address because that one's non-routable, but you get the idea. So it goes from a URL, www.something.com, to an IP address, and then the IP address gets translated by a switch into an ARP address. So it knows exactly which computer to talk to. So that's kind of the chain, and you need to fully understand that. So it goes from www.whatever.com to an IP address. The IP address gets routed along the internet. At some point, the switch or router on that network will translate it into an address resolution protocol address, which is basically a MAC address. So DNS goes from URL to IP, and then ARP translates from IP to MAC address and back and forth, from MAC to IP, and then DNS does from IP to URL. So ARP scan sends ARP packets to hosts on the local network and displays any responses that are received. So it sends ARP packets to hosts on the local network and displays any responses that are received. So you can kind of do a little bit of information gathering about the ARP. And we're going to discuss ARP spoofing, sending ARP packets from another server's MAC address, but it comes from us, and then we're going to make it look like somebody else's packet for different types of reasons. We talked about that earlier. We were doing spoofing for I forget what the tool is called. The idle scan, that's where it comes into play, like that kind of thing. Traceroute. Traceroute is on the test, so you need to know all this in red, basically this entire slide. Traceroute. It's a diagnostic tool for displaying the route and measuring transit delays of packets. So not only does it tell you where it went to get where it's trying to go, but it tells you the path that it took and how long it took for each segment to get there. So it'll make a request, and you'll see lines of data as it hits each point. So the way this works is it sends a sequence of UDP packets addressed to a destination host, and it's going to traverse a bunch of machines along the way. The time to live, or TTL value, also known as a hop limit, is used to determine the intermediate routers being traversed towards the destination. So what does that mean? If I set the TTL to 5, that means at most hop across 5 servers and then stop. So it's going to get bounced around. So say the route is to China and it's going to take 10 hops to get there. A hop is from box to box to box that it's just going to happen to hit. So from router to router to router, right? So each time it hits a device, it'll decrement the TTL by 1. So if it's set to 5 and it needs 10 to get there, most of them I think are set to 30 by default. If it needs 10 to get there, we only say set the TTL to 5, it'll get 5 hops, and then that's it, it'll die on the vine. Because as soon as this TTL gets to 0, they throw the packet away. But you'll see that it destination unreachable, you'll get messages back telling you about this. So you'll have a lab about this, so you'll be able to play with this quite a bit. So we talked about the hop limit. Each time it traverses a router or device, it gets decremented by 1. It's used in determining the intermediate routers being traversed towards a destination. Routers decrement the TTL values of packets by 1 when routing and discard the packets whose TTL value has reached 0. So as soon as the TTL is 0, they just throw it away. Returning the ICMP error message, ICMP time exceeded. The exam has questions. Okay, so this is about ICMP. Okay, this is an important one. You're going to see many questions on this, and this is quite a bit of information to remember. And this also tells you that you need to do a lot of playing around with this tool because it's very useful. It's starting to kind of get turned off in some places, but it depends on where, how hardened the environment is. In a hardened environment, ICMP is almost always turned off. So that's where HPing is going to come in. You're going to need to use other types of protocols besides ICMP for this to work. Because in hardened environments, this will be turned off. Or it may only be turned on in insecure sections of the network. There'll be certain places where it doesn't work. So some devices will just block it. So if you want to make sure a server's up, you ping it. And today, I would be suspicious whether or not that was correct if it said that it wasn't up. So I might use other ways like HPing to kind of verify it. So if you can't reach a server, the first thing you do is ping it. And then you can kind of get some information and start troubleshooting from there. It's basic troubleshooting. There's a time when this was all over the place. It worked everywhere for troubleshooting. That's basically what it was for. And for a long time. And they're just starting to realize that, you know, we need to turn this off. There's other tools that we use, so it's starting to get shut down. So you're going to be asked questions about types and codes in ICMP. What is the code for a destination network unreachable ICMP message? Okay, well, let's take a look. So you see the type column on the left, the code, and then the status and the description. Those are the columns here we're looking at. So under type, you see destination unreachable. That's a number 3. So type 3, code 8 is a source host isolated. But we're looking for what is the code for a network destination unreachable, which is the most common message you'll get when you're having a problem. So that's the very first code for type 3. So it'll be a type 3 code 0. So an echo reply is a type 0 code 0. Okay, so that's how this works. You need to know all of these. Not type 4. You're going to see type 3 questions on the test and maybe a type 0. And a type 8 and type 11. You'll see a type 11 question also. Type 11 has 2, 0 and 1. TTL expired in transit. And so we'll see an ICMP error message, ICMP time exceeded. Let's find that one. So that's an 11. So there's 2 possible codes on that. A TTL expired in transit and a fragment reassembly time exceeded. So there's different types of messaging, and it's giving you further information about the type of problem it believes that you had. Okay, so make sure you study this extensively and play around with this in the lab, or you can do your own lab on this. Not too difficult to do. By the way, this is supported in every single OS and device out there, including Internet of Things. You can also troubleshoot those with this too. Those are probably very subjectable to this kind of interrogation, information gathering.